Hello, welcome back to Tectenum. So today I'll be taking you through the DHT sensor. What is the DHT sensor? Well, first, before you even have a look at the DHT sensor, let us understand what sensors are. So sensors are components of a circuit that are used to measure specific phenomena. Well, in simpler terms, they are just used to measure something. A sensor is used to measure weather temperature, a sensor is used to measure humidity, a sensor is used to measure light intensity. So every physical phenomena, you can use a sensor to measure it, and a DHT sensor in this case is used in the measurement of temperature and humidity. It has a lot of application in electronics, and it's a very important sensor, so we should know what it is and how it works, and then be able to use it. Here are just some of the uses of a DHT sensor. It's used in fridges. We know that fridges are used in cooling, and in cooling, temperature and humidity are physical phenomena that are important. So when the temperature is low, the DHT sensor will tell the fan to switch off, or when the temperature is too high, it will tell the fan to start. And those are just some of the uses of a DHT sensor in a fridge. It is also used in dryers, maize dryers, beans dryers, cereal dryers, and humidity is a factor of dryness. Like when something is dry, it means it has low humidity. When something is not dry, it means it's wet, it means it has a high humidity. So when you use a DHT sensor, you can be able to now measure the level of dryness of that cereal you're drying, or paint, something like that. So a DHT sensor is important in dryers as well. Engines work by burning fuel, and when you're burning fuel, the element of temperature is there. I think you might have heard of something like an engine has blown. That means the temperatures were too high, and it means the sensor for measuring temperature maybe failed or did not detect the right temperature. So when you put a DHT sensor in your engine, not literally put it as part of the circuit of your engine, of course you will be able now to measure the temperature and be able to regulate so that it works within the required range. Electric motors also have DHT sensors, because motors they become as a result of resistance and things like those, they become hot, and when they become hot, they can be damaged. So DHT sensors are used in the measuring of, like I said earlier, temperature. So you would have a DHT sensor in your motor. Another example is rocket engines and jet engines. So these are things that all have temperature and humidity as part of their operation. So they have to have sensors to regulate and help measure exactly what range they are operating in. So those are just a few of the examples. Further, you can also have a look at your own examples. Go ahead and try research other places you can find a DHT sensor. And at the end of this tutorial, I hope that you also have some use for a DHT sensor and create your own project with that sensor, so that you get to interact with it. So here are the topics you're going to go through under the sensor. We're going to have a look at how you can integrate it in our Arduino circuit, or an ODMC circuit, or any microcontroller circuit, because all of them literally work in the same way. So you can, once you know how to do it in one, you can be able to do it in all the others. I also have a look at the DHT sensor module. It's the software that will run your DHT sensor. I will explain further what a module is when you get to that place, or when you get to that scene. We also have a look at how to use it as an input, and this is very interesting because at the end of this tutorial, you'll be able to get temperature and humidity from the sensor from the DHT sensor. So very interesting, and I'm very excited that we'll be able to have a look at these things. So let us have a look at it. So here is the sensor itself. It's a very simple sensor, very small. It has only 3 pins. The first pin on this side, which is on your left side, is the VCC. Then in the middle is the data pin, and the other pin is labeled as GND, which means ground. So these 3 pins all will be used, and this is how you'd use them. So the VCC pin is what you'll use to power your sensor. So this one is the pin you'll connect to your 5-volt on your Arduino. The data pin is what you'll connect to. This is what you'll get. This is how you read the data from this sensor. And finally, the ground pin is the last pin. We just connect it to a ground. So these are the three pins you'll be able to use on this sensor. And straightforward, let us go to how the code looks like. So here is the code for this DHT sensor. As you can see here, the first thing, I've imported the library called DHT.h. Well, what a library is, for every sensor we'll be using, it will have its own library. In this case, this is called a DHT sensor, so it has its DHT library. What the library allows you to do is that there's some code already written, so that you don't have to write every small bit of code, and because this is a machine. If you wanted to like just write code for it, you have to write the code in machine language. But now they have simplified it for you, and then they have put that code inside that library for the specific sensor. So in this case, they have put that code inside the DHT library, and for every sensor you use it to have its own library. And to include that library, you have to include it under, you have to download it into your IDE. How you do it, to go under your tools, then you'll go under your tools, then you'll go to manage libraries. Let us give it a few seconds, then it will show you the interface, which I think it's coming up soon. That interface is what exactly, this is the interface I'm talking about. It's called library manager. So under this library manager, this is where you'll find every sensor you want. As you can see, there are so many of them. Every sensor you want has its library already inputted in here. As you can see, there is Arduino, HTT, every library you want. So we'll go to, just simply search here as DHT. As you can see, it will show you the DHT sensor libraries that are installed, or you will need to install it. Okay, here they are. So you have this DHT, FRobot, whatever. For us, we'll use the DHT, this one, sensor library. So this one will have all the types. For specifically, this one is a DHT 11. So there are so many DHT 22, all of them. But here you'll just have to install it using this button over here. I've already installed it, so I do not require to install it again. But if you have not, you require to install it before you use it. This sensor is provided by Adafruit, and it's what I will recommend to use for these types of projects, because it's a universal library, meaning it doesn't matter what type of DHT sensor you are using, it will most likely work. In this line again, now we say that we simply define the pin that we are going to connect our data pin, the data pin that I talked about earlier. So in this case, I'll be connecting it to pin 16. Because I'm using a Node MCU, I'll be connecting to D0 on a Node MCU, but on a Node MCU, the D0 corresponds to 16 on an Arduino. Here I'm just now importing that. I've already imported. Now here I'm just defining that I'm going to use it as a DHT. In these sections of code, we see that there's the void setup and the void loop. The void setup will only run once. So when you're starting your application, void setup only runs once, and after that it doesn't run again. So in this section, you'll place your code that only runs once, and a void loop, this is a loop, so it keeps looping. So this is the code that will run continuously. So let's define every other line and see what it does. So I've said serial.begin 9600. In this case, I'm just trying to show that the serial monitor, which is basically what we'll be seeing, it's the screen. So we are connecting the screen to application and telling it that what you're going to print on your screen should go at something. The bound rate, this number that you see as 9600, is the refresh rate. How should it refresh? How fast should the output on your screen refresh? As you go further, I'll be able to show you the output on your screen. And then I've delayed for 1000. What I mean by delay 1000, just wait, just pause the program for 1 second, because you're working with milliseconds. And the void loop, like I said, the DHT.read, this will simply, I'm telling it to read the sensor now. I've said, because I'm using DHT 11, I'll use DHT.read 11, then DHT sensor. Remind ourselves that DHT sensor is what I defined here, telling it that is pin 16. So what this does is simply read pin 16, and when you are reading pin 16, remember that a DHT sensor, it is what is placed on that pin. So that is what DHT.read 11 means, this line of code over here. Next, as you can see, serial.print temperature. So what I'm telling the program to do is print temperature on the screen, and then serial.print DHT.temperature. So with what we read over here, now print the temperature. Now print the temperature, because it will come in pairs. It will come as temperature and humidity. So what I'm telling you to do is read the temperature. Over here it says serial.print humidity. So print humidity, just humidity, the word humidity, and then read over here DHT.humidity. Then again read humidity and print it. That is what this line does. And then this one will just print an empty line. So it will move to the next line and then delay for 2 seconds. That is what delay 2000 means. So that is our code, and now let us have a look at how it works. But before we do that, we'll have to compile it and upload it to our microcontroller. What I mean by compile and upload is, because you have now written this code, you have to turn it into a language that your microcontroller will understand, and then send it to that microcontroller. So that is what you do every other time you write code in electronics. You will have to compile it, which means convert it into a language that your microcontroller will understand, then upload it. Now send it to that microcontroller. In this case, I'm just using a USB pin. As you have seen, it's a USB B, because that's what a node MCU uses. And to compile and upload, this is where you will compile, and this is where you'll upload. So because I'm going to do both, I'll just use the upload button over here. So upload will compile and then do the upload. But what compile will do, it just compile without uploading it to that pin. Without uploading it to your microcontroller. So that will take a few seconds, and let's be patient as it does the compilation. So as you keep waiting, let me show you a few other sections. As you can see, I've switched on so that it's able to show us what is happening. As you can see down here, it's giving us a notification, a compiling sketch, and this is the percent of the compilation that is happening. It's just giving you what is happening, because now you can see these are just the logs of what that particular session is doing. I've already inserted back my sensor to my setup, and like I said, if you're able to see, the ground pin is going to my ground over here, this one. My data pin is going to my D0 on my node MCU, and my VCC, which is the power one, is going to my power rail over here. And of course I'm getting the ground and the power, the shared ground and the shared power from my node MCU. So this is how your circuit would look like. It's just the three, not a very complex circuit. So let us wait around as the compilation happens, and yeah, I don't think there is anything else I can take you through. The circuit is just this simple. You can try it out on your own as well, or you can pause the video to have a quicker look at it. I'll zoom it clearer back to my webcam so that you have a look at it. So as you keep waiting, keep thinking of ways you can use this DHT sensor, because it is a very interesting sensor and you love using it. So just keep thinking which project will use for your sensor. And now the uploading is happening, as you can see. It will show you the percentage of upload that it's complete. As the uploading keeps happening, you will see that the node MCU blinks. The Arduino as well, if you are using that, you will see this LED on it blinking. Now the upload is done, and to be able to see the output, we'll go here under Tools and open the serial monitor. I will change here the bound rate to match the number that we are using over here. So the bound rate over here is 9600. Then I will do a reset. As you can see, it's already, keep it a few seconds and it will start printing. Yes, as you can see now, it has caught up. It's telling us that our temperature is 28 and our humidity is 62, and then it's putting the line over there. As you can see, as the values change as time goes by, the values will change from, see, the humidity keeps increasing and dropping between 61 and 63. So that is how you would use a DHT sensor. And now you can know, if it's a complex project, you can use these values to do something by using if structures and things like those. So something else you should note, as the sensor keeps working, this LED that has on it will light. So this LED will light to show that the sensor is working properly. Yes, and that is where we would end our video for today. Thank you.